Hello all, welcome to this session. In this session we're going to be covering an introduction to Unreal and the material system in it. Before we start that, I think it's useful just to have a quick insight overview of what shaders are and how they are in play today. So shaders have obviously been around for many years on devices, and effectively, a shader is effectively the pixel, the color of the pixel on the screen that is controlled by the GPU on that device. So depending on the GPU itself, be it a mobile device, be it a game platform, be it a PC, those GPUs will determine how many pixels and the complexity of the shader material that can be put on display on that device. So within Unreal, now the shading system is handled through what you call a physically based rendered methodology. Sounds very complicated, but what effectively that means is historically the device would have handled both the lighting and the surface material for the shader. But now that's been sort of split, and that the game engine itself handles the lighting directly, and the material then subsequently handles all the surface properties of it. So when you talk about what is a physically based rendered material, if you think about the number of real materials in the world, so you've got metallic materials, you've rubber, plastic, glass, wood, and so on. So the idea of the material system is that it tries to replicate that into a real world material that you can apply to an object within the environment you're creating. So I think it's better if we actually create a material and have a look at this system and how things are put together. So as you can see here, I have a third person project open. The material systs, create a material folder here and a textures folder. So if I go into the material folder and right click, you'll see that at an option, one at the top there is material. Okay, so quick definition of it there: material is an asset which can be applied to a mesh to control the visual look of the scene. When light from the scene hits the surface, the shading model of the material is used to calculate how that light interacts with the surface and ultimately what that material looks like. So again, the material can go from something very simple through to something incredibly complicated. But again, needs to depend on the actual GPU of the device. So if you were trying to run an incredibly complicated material on a GPU of a simple basic phone, that is not going to work. Okay? And again, the more complex the material is, the more demand it's going to put it on even the most powerful GPUs. So they've got fixed amounts of memory, and you'll see here whenever we create it that has to be handled and managed as well. So with right clicking and creating a new material, I think I typically sort of start the naming convention with Matt underscore. So again, whatever company project you're working on, they may have their own name conventions. I'm just going to call this Matt first material, and I'm just going to hit enter and open it. So once you open it, you'll hopefully get something similar to this. I'm just going to dock the window up here at the top. So what I've got here, well, you've got your sort of preview window here, you have your main menu here. Okay, you can file, open, navigate to things. You've got your windows that are associated with the material editor, and say you've got your preview window here. Now yours may look slightly different. You may have something like that. All I've done is turn off the background there, turning off the grid as well, just so it looks like that. Under the lit, your auto exposure may be on there. Sometimes it can mess about with how this looks. I think I'm just going to set it at something like 0 for mine, just to give you try to create a close representation of what it's actually going to look like, the material. Your perspective, again, you can do different viewports on it. You can change, your field of view, etc. And again, just play about with these options down at the bottom here. You can actually change what the material is being previewed on. Like it defaults as a sphere, but really powerful one here is at the end. If you had a really detailed character on a complicated material, you can actually apply the actual 3D mesh in here and apply that model, the material to it, so you can actually see a proper preview. So within this, you've got your core material graph here as such, and this is where you're going to actually build up the nodes that are responsible for the complexity of the material. And as you can see here, all these are areas that you will plug into various bits and pieces, and that's subsequently whatever you amend and select within it will ultimately determine what this material looks like. So currently this material, we've got a details panel for it, and associated things with it is this is a surface. It belongs under the surface domain, but you could change it to decals, light functions, volume, post-processing, user interface, etc. But again, for the sake of this one, we're just going to keep it as surface. The same thing, opaque, under blend mode, but we could change it to masked, translation additive modulate. Just quickly, watch what happens whenever we change any of those settings. You will actually lose or find different nodes and plugins become available for each of the different material modes you can actually work with. So for this case, in this introduction, we're going to leave it as opaque. Similarly, the shading model then you can use will also determine which nodes become available. So if we select it unlit, a lot of the other nodes like base color, etc., become disabled effectively and will be ineffective in this. So you only have a emissive world position pixel offset. But we're under default lit, and you can see these are the sort of core ones, defaults that will appear for you. There are quite a lot more shading models available to you, such as subsurface, clear coat, two-sided foliage, hair, cloth, eyes, etc. They're way beyond the scope of this session, but again, if you had to create a material based around, a car material, the car paint, there's clear coat. Obviously, if you had to create hair, cloth for a game or an environment, same thing. You could start off with these as your base point. But as you can see, there's a lot of settings in this, folks. We could go in and change some of these, but I do want to try and keep this as simple and straightforward as possible. So just to make you aware, we've got a material graph, we've got our the node here, we've got our details, and then we'll plug things into it. So what's the sort of standard things we're going to plug into this? And again, we're trying to think of this physically based rendered system, i.e. trying to create the most realistic looking materials that represent physical content in the world. So core thing there, start off with, is the base color. This is effectively your diffuse, the color or the surface of the actual object, the thing that's going to bounce the light off it. The metallic hopefully is high metal. The object is specular, okay. High the specularity of the object. When you're looking at the reflectivity of it, the roughness then is like if you compared to objects in the real world, like a glass ball. So super smooth, clear. The surface is very smooth. There would be no indents. It would be very smooth to hold in your hand. But if you had a block of coal, or a block of coal would work. Dark material, very rough. Whenever light bounces on it, doesn't reflect anything of it. So that effectively, if you were looking at that under a microscope, the surface of the coal material would be very bumpy and rigid, meaning the light isn't being reflected as anywhere near as good as what the glass material was. Again, if you looked at that under a microscope, it would be super smooth. It would be like dent free almost. So that's why you'll get a rough and smooth sort of looked at different materials. So again, you would have to think if you're making a rubber material, wood material, how rough is it? Is it a super smooth laminate, or is it like an old ingrained bit of driftwood, something like that? You would need to think of it. How metallic is the object? Is it a brush metallic? Is it a super shiny metallic? Again, these are things we'll look at very quickly in this tutorial. And under emissive then, we're going to leave anisotropy out of it there, just as you can see, but whenever you hover over it, determines the extent of the specular highlight stretched along a tangent, but again, probably beyond what we want to do in this tutorial. Emissive, how your objects will glow. So probably all like this one, very useful as well. You see it was one of the core things under unlit. We'll look at that. And normals, what is a normal map? Well, effectively, a normal map is a texture you're going to be able to apply to the surface of a material that gives it the illusion of detail on it. So it defines like the shape of the surface. It'll each pixel on the surface would have a vector effectively pointing from it. And what happens if you shine a light across it? It gives the illusion that there's a depth to it. So again, you'll see that here better with examples. So I think just to get started here, we're going to create a standard diffuse color. And we're going to say, right, we're going to start off with plugging something into it. So I'm going to start off with a simple float value. So a float is a single value, a single number. And we're going to build this up subsequently. So if I took this value of 0 and plugged it into base color, nothing has happened. Awesome. But if we start to change this value, so again, we can change the value here inside the node, or we can change it over here under the details panel. So if I change it to 1, it becomes white and it updates. So a value of 0 in color terms is black, and a value of 1 in color terms is always white. So if we change it to 0.5, you can see it's a subtle shade of grey. And then if we went a bit lower, darker shade of grey again, darker shade of grey again, 0, black. And then subsequently, if we went up to 0.9, it's very pale grey, 0.8, 0.7. Hopefully you get the idea. So effectively, all we're doing there, this is probably one of the most simple materials you could create, but we're going to make it a bit more fancier. So if you think of a color is made up of 3 things, a red, a green, and a blue pixel put together. So we need 3 values. So instead of hitting 1 on the keyboard here and left clicking, I'm going to hit 3 and click. And you get this value appearing called the constant 3 vector. Wow, okay, what is it? Folks, it's 3 numbers. It's a node that holds you 3 numbers. Now, it doesn't have to be a color. This could be 3 values that you're using to do all sorts of magic in the material, but for this case here, we're going to use it so that it takes a red, a green, and a blue value. The great thing about this is we can actually click on this area and we can change the color wheel. So let's say we want, I don't know, something like that. And click OK. You'll see that this updates. And what we could do is, don't make the mistake of dragging from those, because if you drag from here, the red, effectively you will get this value. If you drag from green, red, green, even though it says Y, so red, green, blue, X, Y, Z. So green would give you a value of 0.8. So based on what we did previously, this should be, hopefully, if you're saying what color it should be now, a lighty sort of grey. If we use the first value, what color should it be? White. Yeah. So again, just be wary of where you're dragging from in each of these things. So the one that we want is actually the top. This is all 3 values, and if we drag all 3 onto the base color, you'll see now that we now have this yellowy type surface. So again, most base colors will be very flat looking, just like what we're seeing here. Not always a color you would use. So sometimes you would want to use a thing called a texture. So a texture is the actual asset that you would make in Photoshop or Substance Painter. You would make it of a certain resolution, like 1K, 2K, 4K, 8K sort of texture. Then you would import that into the game engine. That then subsequently you can use within the game engine here is what you call a texture. So I'm going to hit T. Or actually, I'll do it a different way. I'm going to right click and you'll get this context menu come up. So I'm just going to hit texture, sample. So this is what we're looking for here as a texture sample node. So by me holding T and left clicking shortcut, you'll get the exact same thing. If you go over to your palette here, you'll get a palette appearing for everything you can do within the material node. So quite a lot of things, folks. We're not going to look at all these, but it's just to make you aware there's a super, amount of functionality available for you at your disposal here. So we could have went in there and just typed in texture sample as well. Got the same thing there. And then, dragged it into the world. So to me, T and left clicking, quite easy. So if we had, whenever you add these nodes, by the way, remember the details panel also updates. So if we select the texture sample here, you'll see that it updates too. So the thing that we want to change here is the texture we're actually going to apply to it. So within the engine here, I think there's some default content. I'm just going to select the first one here, this brick clay beveled, and you'll see that the texture then subsequently updates. Now, same thing, don't want to drag out off these here because these will actually relate to the different channels available within the texture. So the one that we want is all of these channels put together. And then if we plug that into the base node, we now have a surface there available with this brick look on it. Now, similarly, we can change, remember what I said, we can change what the view is there. So totally up to yourselves which one you want to use. For this sake, I'm just leaving it as the sphere. Now again, looks very flat, not much detail to it. So let's fix that. First of all, we'll look at the color one. So we're going to plug it back in. And what we're going to do is add something to these nodes to jazz this up, to make it a bit more. So we're going to go for like a metallic type gold material here. So we need to obviously plug something in here. So what do we plug in? Well, a metallic node, a metallic plug here takes a value of between 0 and 1. So anything outside 0 and 1, the engine's going to disregard. So if you typed in 4, it'll clamp it to 1. If you typed in -27, it'll clamp it to 0. So just be wary of that. So how do we add a node here again of a single number? What was the very first thing we did? Hold 1, left click, and this brings up a single float value to work with. So if I plug that into metallic, you'll see here no difference whatsoever. Why is that? Well, we're telling the system here that there is no metallicness to this because it's at 0. But if we change that to 1, look at what happened to our shader now and the material. So we now have this, dull looking gold material. Now, just to give you an example there, if we change that to 8, doesn't look any difference. If we change it to -4, it goes back to flat because again it's clamping it. So -4 and is the same as 0. So you're always dealing with between a 0 and 1 for like the specular roughness metallic. Okay, so for our case here, we're going to pump that up to about 0.9. So we've got a nice sort of sheen there going on, but we want to make it a wee bit more sparkly, let's say. So same thing again. If you right click, just type in constant. It's the exact same thing. Okay, constant float, a single value. And we're going to plug this into roughness. Now, watch what happens here. What we're saying is that this material is going to have no roughness at all on its surface. So now the material, it's a metallic material of 0.9, but we're saying here the surface is perfectly smooth, not a dent in it at all, and you get, funny enough, a very reflective material appearing there. So if I went into the game here itself and we applied that to a surface, so we just dragged it on there, or you could select this and then it'll actually use the asset we've selected in the browser. Okay, So if we hit play, went over, you can see that the actual metallic gold has been applied to that. Okay, so hopefully this physically based system is making sense now. So if we wanted a dark coal looking shader, how would we do this? Well, it doesn't have any metallicness to it. Hopefully that's the right word, metallicness. I'm going to presume that it is. And we could bring it down to something quite dark. Now, coal is not actually a value of 1. No, there is no object that has a value of pure black, and there's no objects out there in the world that has a value of pure white. I can't remember off the top of my head of them, but it's definitely not. Snow is not 0, and coal. So if we bring that in, you can see that we have got this super cool looking, super shiny material. But let's just bring it up ever so slightly. Okay, so we've got this sort of level of black on it now, and then what we're going to do is, because we know coal is quite rough as a surface, let's put it up to something like 0.9. It's almost like a chalk as well. You could probably, so you'll see now that the material has been updated to that. Yeah. So again, it's a matter of working with these values here. If we change the specular value of roughness to 0.5, specular highlights to 0.5, you can see that you're almost getting like a rubber sort of material now. So specular, you usually want to leave about 0.5. It would be never 0 and never 1. 0.5 is pretty a solid value to have for it. Then your roughness then, so if we took the roughness down to 0.2, you can see there it's like let's change the color of it here. Let's go to nice pink balloon. So, okay. So by changing these parameters, their specular, their roughness, and their metallicness, then you can create rubber, chalk, metal, all sorts. So we can also do then the same to a texture. So I'm just going to disconnect these. So all I'm doing is holding Alt and clicking on them. And I'm going to come back here and drag our texture into this. So you can see here it's quite flat. And what we want to do is add some sort of fake detail into it. Well, if you recall from earlier in the session here, I said that we have this normal map node available. So if we go to this texture and look at it, T, brick, clay, bevel, D, I'm actually going to hit T and create another texture. But this time we want to look for the normal map version of it. So you can see here, if we scroll down, you'll see this like purpley, bluey, green. So I'm actually just going to look at it in the content browser here with you. You'll see this type of material. So if you ever see this in the game engine, this sort of look, blue colory, blue, turquoisey, pinky type material, you can be pretty sure that whenever you look at it on the texture settings, that it will be what you call a normal map. So this is the texture that's actually going to give you the illusion of detail on the surface of the material. So same thing here. We don't want any of the individual channels. That in this case, sometimes you might, but in this case we don't. We want to drag out the RGB. Now watch, whenever we do this, watch what happens to the detail on the surface here. So now we've got this detail in between where the cement will go. So if I just quickly disable that, once again, very flat, no detail. But when you drag the normal on, you start to get that illusion of detail coming onto it. Now, we could plug in other things here, roughness. So how rough is the brick? And you can see here, well, we've actually said the brick is quite smooth. But let's put it up to something like 0.9. A brick would typically be quite rough. Again, not a lot of detail on there. That's maybe too much. Let's bring it about 0.6 or so. Maybe a bit more of the detail there. But let's say it was raining and wet or something. Brick has absorbed everything and it's now porous, and there's water gathering on the surface and being able to run off it. Well, if you took that down to 0.2, you can now see you've got almost like a wet brick type effect. Now again, that would be another more complicated shader. You could also bring in metallic this, why you would want this, but who knows. But now you've got metallic brick surface or something like that. You can change it to 0.1. Okay, if it's fully metallic, leave it as 0. So that's it without the metallic. But if we take that up to 0.9, look what happens. You get this like chrome, super chrome effect on the surface. So this is your physically based rendering thing, folks. You know, you're taking colors, your base, your diffuse, putting it on there, then you're determining these other parameters around it. What's the metal level of it? What's the roughness? What's the specular? What's the normal on it? And you can bring these things together. So hopefully that's enough to get you up and running on that piece. Things that we should probably consider then as we work on this. You'll notice here, if you don't have this down at the bottom here, your stats panel, it's always very useful to have that enabled. So under your window, make sure stats is showing there. And you can see here that this thing here is causing this material will require 226 instructions to run on the platform you want to run it on. So the more complexity you put into this, so if I was, for instance, take away the normal of this, watch what happens to the instructions. It's actually went down to 219, so it requires less power to run this here on a GPU, this alone. But once you add the normal in, it's requiring an extra, 7 instructions to run on the GPU. So again, going forward, just be wary of that. If there's things you're plugging into this that you really don't think you need, just make sure they're disabled, because each of those instructions will ultimately add up. They'll all use up the video memory on the GPU, and then you can cause all sorts of problems down the line. So you want to try to be as efficient as possible with your materials when you're building them. So the other thing is then, for those who are curious, you could actually have a look at the code that this generates. Not really necessary in any of the things we'll be covering. But if you think about it, this is the visual representation that Unreal has given you to create the shader effectively. This then subsequently gets converted by Unreal behind the scenes when it gets compiled into an HLSL. So if you come down here, HLSL code, which is high level shader language code, and you can see that it's actually down here. So this actually is code that gets associated with this shader you're actually building. So thankfully you don't need to do anything with this. And if you were employed within a company as a texture artist or whatever, you will probably need to be able to decipher and work with the teams in this. But thankfully for our case here, we don't. Once the HLS code, by the way, just for the, might as well finish off the pipeline here. So you're creating a visual representation. This subsequently gets converted to HLSL by Unreal. That then gets passed to the API on the device. So that would be maybe DirectX, OpenGL, or Metal or something like that on the Android. So effectively then and gets converted to assembly language, which then subsequently gets passed to the actual GPU driver, and then that does all the magic, and ultimately the thing gets displayed on screen. So you're seeing the first step of what maybe four levels there before that actually shows up on the screen for you on the device. So you have a lot going on behind the scenes there. Let's see what else. Just there are maths nodes we could do here. So we have looked at some maths. We have looked at what you call float values. So we have looked at a single float, which is one value. We've looked at one with 3. Funny enough, there's if you hit 2 and left click, there's a node that gives you a 2-number system to work with. If you hit 4, there's a 4-value one as well. So red, green, blue, alpha. And again, you don't need to use it for color. You could be using it for 4 numbers. We could use things like maths, like linear interpolate or something like that. So we could lerp between two values there. You can have a par node. You can have add 2 things together. You can multiply. Get it? Divide. And then subtract. So you actually have maths available to you here, and each of these nodes, when you combine them together with things, will give you a different setup. So let's do one for quick sake here. Let's add another texture. This time I'm going to select a different normal map. Let's go for _n. Don't want to be too fussy here. This rocky material here. So what we can do is we could take the RGB of this and add it to that. We could take the RGB of those two together, and then we can plug this into the normal map, and look what's happened. You know, you've really pushed the boundaries there of, you know, adding 2 of these together. So this is actually giving you what happens when you interlink these 2 textures together. So we could do that. Let's break this one up here. Let's lerp. Let's use the lerp node here. So I'm going to hold this and hit Control D just to duplicate this one. So let's go to pink. Let's pick a different color in this one. We'll go to, I don't know, green or something like that. And we'll plug the pink one into A, and we'll plug the green one into B, and then we'll link that into base color. So I'm just going to set that back to 0. I'm actually just going to disable these metallic and roughness here just so we can see this really clear. So this is a system that creates like a graph system behind the line. So, you know, A and B, and then what happens as we change this value. So what this is saying, at value 0, it's going to use all A. If we change it to 1, it's going to use all B. So if we change it to 0.5, this is what we're seeing between the 2 of them. So if we want to 0.1, 0.2, 0.3, you can see here it's slowly changing. 0.4, 0.5, 0.6, now it should start to go green. 0.7, 0.8, 0.9. So what you're to be able to do there is lerp effectively between these 2 values. And again, it's something we'll come across and use more examples going forward here. So it was just to make you aware that there's an incredible lot of functionality available within the material system in an Unreal. But hopefully that's clear enough. I think what we'll do is just have a quick look at the actual textures that make Unreal up as well. So if we select our brick texture, okay, so remember, I'm going to find this in the content browser, and I'm going to just double click on it here. So if you recall, these textures are the actual things that have been made in Photoshop or Substance Painter or whatever. And these are the things that we use as a texture sample to put on our materials. Just to have a quick nosy at this here, whilst it's available, you can see here that this is 2048 by 2048. So what does that mean? Well, that means this is a 2K file. So if we were to, see this value as being 4096 by 4096, that would be a 4K texture. Okay? So that itself is very important, because ultimately you can see here when Unreal brings it in, so this file itself may have been 50 megabytes or something, and actually when we work on that out, so direct this type of compression here, I think is an 8:1 compression, so this would probably have been almost maybe about 50 meg in Photoshop when it was created. So whenever it gets brought in the Unreal, it's been compressed using this compression algorithm here. Okay, and there's a lot of them to choose from here. So you can see that if we select that one, it's actually brought this down to 5 meg. Now, what you could do here, and again, this is quite important, you'll see that there's this sRGB feature enabled. So typically, because we know this is a diffuse and it has color, you would always want that enabled. But any other texture that's being used for like normal, etc., you can disable that option. So just be very, you can be wary of that. Other ones here, then this is a very useful one here, maximum texture size. So because we have said this is a 2K file size, and again, it may be not suitable for, say, we want to use this texture on a mobile phone or something, but 2K is quite a bit overkill. You're not going to see that level of detail on that sort of device. But what you can do is you can actually override this, and this is what Unreal will compile it to. So say, for instance sake, we wanted this only to be a 256 by 256 texture size. Watch what happens to our resource size whenever we do that. It's now down to 85 kilobytes. So yeah, it might be perfect, and you wouldn't want to use it in a AAA game, for any sort of hero assets. But for mobile phone stuff, might be fine. Again, if you even wanted to half it, you can actually see that it's almost lost 4 times the value. So each time you come down a compression level. So if we just go back to 1024, we'll revert it. So there's that it's at 5 meg as such, but just by reducing the texture size by what you think is half, it's actually 4 times you're losing there, because that would have been 2K by 2K, so you're actually a quarter of the size. And then same again, bring that down a quarter of again, and you're down to 340. Divide it by 4 again, you're down to that. So again, you can be very careful. Even if you import a really high res texture, an 8K texture, you can tell the engine will actually just stick it at 2K. That would be absolutely fine. So you can do that. So let's say the other things you can do here is your compression settings. So under this, you could select if it was just a black and white file, you could use grayscale or whatever. You'll see here if we change it to a BC7 one, DirectX type texture, you'll get a different sort of settings up there. But we'll put it back to that. This one here is an interesting one, number of MIPS. So MIPS are effectively a means for Unreal to shrink the texture size like dynamically as it needs to. So it's a bit like level of detail for a mesh. So the further away you are from a texture, Unreal will actually start to scale the complexity of it down. So it's saying here this has actually got 12 MIPS associated with it. So there's actually 12 versions of this below it. So Unreal will create a 1024 by 1024, 512 by 512, 128, 128, 64, 64, 32, 30, all the way down to probably 4x4 or something. So if you're super far from the asset with this texture on it, that's the actual texture that I'll put on that asset, because you're nowhere near it, so you can't see the detail on it. So there's no point in still loading the 2K texture onto that asset. So it'll lower it down for you. So incredibly, that's a really useful feature to help save, the GPU memory getting overloaded. There's no point in it loading a load of options into it. So again, I thought that was useful here, just for you to see. So that's your details file. A lot more options, but we'll come back to these as and when needed. You can come in and increase the brightness, etc. on things if you want it here, rather than you come back in the NART package. The Power of 2 mode, really, when you create any asset, any texture for Unreal, you're always better trying to stick to this sort of detail, the Power of 2. So 16 by 16, 32 by 32, 64 by 64, 128 by 128. That's the sort of resolution that Unreal likes to deal with. So if you brought in something weird, it will round it up to it. So if you brought in, it was like 510 by 510, it'll actually change it to 512 by 512 just by padding it out. And again, best practice is just to make your assets in Photoshop, Substance, whatever it is, to match that sort of standard there. Other things here then, so when you bring it in, you can actually change. So currently we're seeing all 4 channels here. We could disable those, and there's what the alpha channel looks like on its own. Okay, so if we were to go back to our node here and just drag out from that, okay, that is what you would effectively get shown on the material itself. Same thing if you were to drag out the red, that's what you would get. Okay, drag out from the green, that's all you would get. Drag out from the blue, that's all you would get. Okay, so there's our MIP details there. So if we were to change that there, did we? Yep, so we're actually back at that. We can see what our MIP levels actually look like there. So there's MIP 11, and that's effectively what it gets converted to on 0 by 0. A small dot. I don't even know if YouTube or whatever your compression I use here in the video will see that, up to 9. Okay, so you can see hopefully the MIP detail working in tandem there. So we've covered quite a lot in this video. Hopefully that makes sense. So effectively, we've looked at what a shader is. We've talked about converting and creating a material there using the PBR setups. We've built up a simple default lit material using textures and constant 3s, colors. We've brought in normal maps there. We've done a small bit of mavs on things, and then subsequently we've looked at the actual textures as well here. So you can see, just quickly opened that normal one there before we finished. You can see it's a 1K texture, and you can see here the texture group in it, the compression setting group in it is normal map. So it wasn't the default DX. So whenever you import a normal map into Unreal, it actually knows that it's a normal map through how it's been created. So again, very useful here. This one is 11 MIPS as well, etc. So fingers crossed that was okay for you. This is a really quick introduction to materials. There's so much more to it. Create so many amazing things. There's so many more functionalities and features in it. We'll have a look at those in the next session for materials. But hopefully that was a useful introduction for you. And I'll see you in the next one. Cheers.